Please join me in welcoming Teja. Thank you very much.
Let me just say this is a great auditorium. I really love the space, and I will be relying heavily on some speaker notes for this. Is this the clicker?
Yes.
Okay. Oh, that's fine. Okay. Hi, everyone. Thanks for making it to this talk. So what I'll be presenting today is an overview of some of our learnings from designing and building XR-based command centers on federal and industry projects. And I'm sure I don't need to explain extended reality to this audience, so I'll just get on with it. So show of hands, how many people here have been in a command center or understand what a command center is? Okay, that's okay. So since we're in the DMV area, I thought like there'd be more, but this is good enough. So for those of you who are unfamiliar with what a command center is, it is basically a centralized location where an organization or team aggregates information in real time. They process it in some way, and it helps to make decisions for a team on site somewhere performing an operation, like which could be a first responder operation or a military operation or just physical security for a building. So again, there are different kinds of command centers, like I said, for handling different kinds of situations. And each of these different types of command centers have different priorities when it comes to the kind of information they use to make decisions. They'll have different scales of aggregating data, and they might be bound by different constraints in terms of the cost or something like network bandwidth that's available for streaming in information. Oh. Okay. So how a traditional command center usually looks like is it's a large room with a lot of physical screens displaying, let's say, high-res video or information dashboards coming in from web apps or desktop apps. So it has a lot of networking equipment and a lot of people who are usually on site for security reasons. And on the one hand, this amount of equipment and co-located personnel might be seen as necessary for like effective real-time decision making. And on the other hand, there are many cases where having, I'm going to quote, fat and ponderous command centers with a large physical footprint, it'll have more downsides as you might expect for some situations. So firstly, it's a downside when you're trying to stay mobile, for example, in a first responder situation, and you have to deal with the logistics of moving personnel and equipment to respond to a situation. And second, these command centers have challenges with scalability. For example, if you're trying to add like a few more displays, you might have to deal with a lot of challenges when it comes to your supply chain logistics. And when setting up a command center, cost is of course a factor, and its priority can determine some constraints like I've mentioned before. So a recent article in the US Army Review referenced some of these issues and cites the need to make lean and agile command center posts. So there's also another issue, and that arises when you need to provide situational awareness to someone in the command chain, and they need to take a decision remotely, but they can't get to their command center. And this happened in 2020 during the pandemic, when the watchstanders, security officers, and other command center employees couldn't get on site and actually access that video wall. So in this case, there was a significant health risk, obviously, and a time cost to getting on site on a secure facility. So our approach to tackling these challenges uses extended reality technology, and the objectives of our R&D efforts are to first reduce the physical footprint size to allow for more mobile command centers, and so that they can be deployed quickly at the point of need. And in essence, this means building an XR interface that allows the user to just put on an XR headset and work with their existing command center software, as well as seamlessly bring in 3D content. So we are simultaneously developing effective ways to augment how information is visualized using a 3D workspace. And again, this is a theme that I've seen in most of the presentations here. We're not trying to replace the existing workflows. We're trying to augment the capabilities of a traditional command center with a relatively more mobile form factor. And so how do we go about designing this? And how do we decide what makes sense for XR? And we've learned a lot from the prototypes we've developed for a few different groups. So I'll be talking about some of the UI, UX examples from our work with NIST for first responders, with the US Navy as part of one of their field exercises, and industrial security as part of an unmanned gold mine. So I'll be talking about 3 specific challenges that we've tried to focus on, and all of these are in some sense related to the gap between the expectations people have for XR and what is actually practical in on-site or in the field. So these images from Iron Man and Minority Report are pretty much like what people have in mind when we present demos to people at events like this. And sometimes these work in a practical setting, like using hand interaction, but sometimes they don't translate well. So the challenge is to design the UI by first identifying specific use cases where XR realistically augments the conventional 2D workflow. And that only happens by talking to the stakeholders and looking at the needs which are not fulfilled by the established workflows. And this can mean, for example, for a command center, it can mean better utilization of existing 3D assets and referencing those with, for example, maps. Secondly, you also need to ensure compatibility with existing workflows. In this case, it's with the video wall equipment and the desktop softwares or web apps that people at command centers use. And third is that the XR workspace is 3D, and so it provides a large volume for visualization. So you need to optimize visualization in a way that reduces visual clutter as well. For a command center, this is very important because you have a large amount of real-time information coming in. And so you need to have a good way of filtering information. You need to allow the operator to filter out the information that they need at any specific time, and also provide the interaction mode that provides the best experience. So let's talk about the first talk about the specific use cases where 3D data and XR make sense for a command center. So there are many multi-dimensional GIS data sets already collected by various federal and state agencies that are publicly available. For example, the US Geological Survey has its 3D elevation program, and which is basically LiDAR that provides national baseline for high-res topographic information. And Google Earth, Apple Maps, and Bing also have their 3D map offerings. They basically construct 3D reconstruction by using satellite imagery. And also some cities in the US have been creating detailed point clouds of specific buildings as part of their smart city initiatives. And for example, we participated in the NIST challenge last year where we had access to point clouds from the city of Memphis. And the idea is that these kind of data sources could help with GIS integrations for planning or emergency preparedness. So the strength of using XR with this kind of data is that, from what we can see, is it offers switching between an accurate real-time picture of the overall situation and a way to have a rough or simulated first-person view of a region of interest. So being able to ingest video, sensors, sensor data, and other geolocated 3D data, if you're a commander in an operation, it will allow you to see all the assets, cameras, and personnel within a physical space of an event. And for example, these images are from our XR prototype we made for NIST. And this was, the users were first responders. And you could see personnel moving through the point cloud of a building that they were at. And you can see their heart rate, temperature, etc. And their body cam view, also you can see that perspective from their location because the display on the video wall is connected to where they were in the point cloud. So this kind of like the perspective switching between first person and third person isn't a particularly novel idea when it comes to research literature, but how we implement perspective switching via the UI in a way that is quick and seamless with your traditional 2D workflows, that is where we can have multiple approaches, and that's where XR can add value. So in the previous slide, I showed some body cams being referenced from like personal on the point cloud to a video wall. So the approach that we take is usually having all the assets georeferenced on a map or a point cloud and allow the user to either select a map pin to get a live camera view of that location. Oh, wait, that's a video that's supposed to be playing. Did it play? Okay. So yeah, you would have everything georeferenced on a 3D map, and then the user can select what perspective they want to switch to by clicking on a map pin representing a personnel or a drone or anything. And you can also view 360 cameras, which work really well in an XR workspace, as you might have seen in all the XR demos. So if you have a 360 camera at a location, you can get a quick perspective switch to that location and check out what's going on the ground. So yeah, the operator can get a rough idea of an area like a city block by using a building layer overlaid on the map as a mesh, or you can get the first-person view of the interior of a building by overlaying the BIM model on top of the map and allowing the user to switch between a tabletop and street view for better like remote guidance, basically. So the user can switch between a bird's eye view and 3D model, and these are very real use cases that are being considered for first responders by NIST and for unmanned industrial facilities in one of our projects. So there's a real need to at least having a rough 3D model. It doesn't need to be highly accurate. It needs to be good enough to provide some amount of remote guidance that will help save time, if not cost. Okay, and I'll also show you an example of what we did for the Navy. So this is pretty much like a map which is showing like a 360 view from the point of view of a drone. So the idea is you can have an unmanned drone and you can switch between multiple drones out in the sea, and you can check out what's going on at different locations in the sea. And what you're seeing there is basically the 360 view. It's not pass-through, it's the actual 360 video. Okay, so that was specific use cases for XR, which make sense for a command center. Coming to our second objective at Headwall. So when the value proposition of XR is that it allows you to make effective use of 3D or let's call 360 video 2.5D assets. So we need to ensure that the UX for the 3D workflows seamlessly integrates with the existing 2D workflows. And again, this is a theme that you've probably seen all throughout this event. So the current workflow as a command center operator will involve working with a lot of desktop apps or web apps, for example, for tactical awareness. So there's something called WinTAC, or you can get additional context about weather or wind speed from a different app, and you're dealing with integrations involving networking equipment, matrix switches for video. Video might be coming from PTZ or non-PTZ cameras. For people who are unfamiliar, PTZ is pan, tilt, zoom, so you can move the camera up and down, etc. And you might have physical security software, which is handling the access control to a facility. And if you have a remote VM, you might want to like switch to a different VM right on your virtual video wall, and you might want to control it using a mouse and keyboard. So ensuring compatibility with existing workflows in a command center has multiple aspects to it. And this could mean, for example, first, easily transitioning between a user's desktop and the 3D workspace with a single step. And if you come and visit our demo booth, you'll see an example of this where you're able to transition between the VR workspace where you have the virtual video wall, and then you can, with a single click on a desktop display and just switch over to that computer. It could be a remote VM, so you can do KVM switching there. So the second is reducing the friction for the same actions you might do in 2D easily in 3D. I gave the example of a pan-tilt zoom camera. So if you have a virtual video wall, let's say 20 cameras, the operator can just like in XR, they can just like do the pan-tilt zoom operations easily, and that's what they do very frequently. And another example is like if you have a map like I was showing before, and you have a set of map pins which deal with doors, for example, you can just unlock a door by clicking on it, or if you have an alarm which is occurring at a certain area, you can just see where that is, and by clicking on that alarm, you will change the video wall to show what is exactly happening in that area. Okay. So again, you would need to perform user testing to understand what the optimal interaction mode is with different workflows. And what I mean by that is we have hand tracking and keyboard, mouse, and controllers. You can use all these interaction modes simultaneously in our XR command center. And that might, just using hand tracking might reduce the amount of equipment you need to have in your supply chain. And that's great, but we found that hand tracking might be intuitive for maps. It's really fun, like zooming in, zooming out, panning maps using your hands. But it might be error prone for other apps which are basically built with the keyboard and mouse in mind, right? So you need to accommodate for that, and there is some amount of user testing that needs to be done to figure out like how would you switch between these two seamlessly if you have an XR command center. So XR also extends the current command center workflow because, again, it is a much larger visualization volume. So you can have, as opposed to 20 or 30 screens, you can have like 100 screens. They can fill up your entire space. But again, this leads you to a problem, which I've already hinted at, and that is visual clutter. And most of the images that I've shown before are from our older prototypes. You might have noticed like lines going crisscrossing and causing a lot of clutter and a lot of screens. So those are from our older prototypes. And our third objective related to that is reducing this amount of visual clutter. And the triggers for that could be gaze-based. For example, in the Vision Pro, you're seeing you have gaze plus hand interaction, right? So that eliminates a lot of misclicks, because you need to show intent to actually interact with something. And the other thing is, I don't know how much you saw of the video, but there was a feature where you can direct a user. You need to allow the user to search for elements in such a cluttered visualization. So if you want to search for a firefighter in that point cloud, you can just click on a dashboard and it'll show a 3D highlight on top of the firefighter. So a lot of the principles here also come in from game design, heavily influenced from game design. So hiding and filtering information is also especially useful for GIS workflows in 3D. For example, when you have multi-dimensional data sets, you want to either hide or change the opacity of a map layer to highlight something. And again, these are not new findings when you consider the research done on GIS visualization or data visualization in general. I'm just trying to highlight that the issue might be more complex in XR because you have all this unrestricted 3D volume that you can just fill with content. So there are still open questions on how you adapt the basic principles for 2D visualization of large data sets to arrange information in a 3D workspace. And for command centers, again, you're trying to optimize the current content arrangement to make effective decisions, to provide better situational awareness. So even if you have increased the number of screens, your UI needs to allow the user to arrange them in a way that makes sense to them. For example, with the georeferencing. So I'm coming back to the slide just to say that the expectations for XR, whether it is for command center or any other application, these expectations can be met with some creative UI, UX design, and a practice that involves users in the design process. Again, a common theme in all these presentations. So, however, first we need to be very realistic about where XR actually augments the current user workflow. And second, we need to ensure compatibility with existing workflows. And third, we need to make good trade-offs between better user experience and the larger pixel volume for visualization. Yeah, I hope this presentation was informative. I'd like to acknowledge our collaborators for the visuals in this presentation. And yeah, if you have any questions, please feel free to ask them now. You can also reach out to us at our demo booth. Thank you.
Any questions?
I know this is the last presentation of the day and everyone's tired. No.
I think people know there are cookies out on the table. Maybe that's part of it.
Feel free to visit us at our booth if you have any questions. Yeah.
Just real quick, whenever I see the Minority Report interface, I flinch. Have you ever had someone come in referencing that or the Iron Man or any other of the, the movie-influenced interfaces where you've just had to say, no, that's a bad idea? And how did they respond?
So everyone wants hand interaction because it's, I mean, all the latest headsets have it, and it just makes sense to them in when they're imagining a use case. And also it makes practical sense in some way. Like I mentioned, like you just reduce the amount of equipment you need to handle, and that makes it easier to just transport. So the way that we've been approaching it is we start off people with the keyboard mouse interaction, and then we say, okay, we're gonna switch you over to the hand interaction mode now. And suddenly there's a lot of misclicks, and suddenly there's a lot of like, just so many problems with the UI. And we also have a hard time balancing it. If you visit our demo, you'll see like we've made some good efforts. But again, like it's a tough sell to convince people who already want hand interaction, but the best option is to give them multiple modes and allow them to like switch off whatever they don't need, and that's what we've been doing. Thank you for the question. And yeah, everyone references Iron Man in Minority Report.
Any other questions?
Again, great auditorium. Like University of Maryland doesn't have anything on this.
Join me in